Live. Hey everybody, welcome to the first International Marmot Video Party, which is Eris Industries' term for a Google Hangout, because I get to create the meetups and therefore annoy everyone with the Marmot meme I'm trying to create. And today we're going to walk through with Casey Kuhlman, our CEO, and Ethan Bookman, our core developer for blockchains, a tool which we call EPM, or the Eris Package Manager. And what EPM basically does is it allows you to create chains, deploy contracts on those chains. So we're going to show you how to do that. And also it can run Ethereum in Tendermint. So Ethan's going to talk a little bit about that. So yeah, marketing aside, I think it's time to turn this over to Casey because he's the one you're all here to see. So let's get rolling.
Excellent. I'm just turning on my screen here quickly. Everybody, can you guys see that? Can you see my screen?
No, not just yet. Okay, that's great.
Awesome. So as Preston said, EPM is our command line blockchain and smart contract package manager tool. What I'm going to do quickly is go over some of the functionality that we use to manage different blockchains with this tool. So if you can see here, the simple help menu for EPM displays all of the commands that it does. I'm going to go through a few of these, and what we're going to do over the course of talking through this is we're going to make a Thelonious blockchain, and we're going to deploy some smart contracts to it. And we'll use what the contracts that we have developed for our To Gather application, our small video sharing distributed application. We'll deploy those contracts to the newly created Thelonious blockchain as we go along here. So if you can see the screen okay, generally the first thing that you'll do is just EPM new. And whenever you do EPM new, you'll generally give it a command. Sorry, you'll generally give it a name for the chain. So I'm just going to do EPM new, and I'm going to give it the name of To Gather testing again, which is an incredibly long name and not very good. And then what you're going to do, usually, but not always, is you'll then check out the chain. So because EPM is meant to handle different blockchains, all working locally, it uses the concept of having the chain be checked out, which, if anybody is familiar with Get, it works more or less exactly how Get checkout works. It just moves the current thing into the directory. So when you do new, it'll pop up a quick Vim instance for you, unless your editor is set to Emacs, in which case it'll throw you into Emacs. And what we are looking at here is what we call the genesis.json. These are the settings that control how the chain operates. These settings are kept in a JSON file, and then that JSON file is read by all of the nodes that are interacting with this chain. So I don't really need to make any particular changes to this too much, but I am going to change one value to unique so that we get a different chain ID. So then once you get through that process of just editing that one simple JSON file, then at this point you have a chain that is ready for you. To see the chains that you have built locally and are using locally, we just use EPMRefs references. And this will show you the name of the blockchain that you have, the chain ID, as well as the chain type on the second column of the table that's displayed, and then also the keys that are associated with that blockchain locally. We also have the ability to easily create keys, so EPM key gen, and you can give it a name. Whoops. Sorry. Oh, wait. Is that not in master? Okay, anyway, in the '09 release, that
Sorry,
EPM.
it's EPM Keys space gen.
Oh yeah, sorry, EPM Keys. Sorry. There we go. Okay, so then we have a small key that has been made for it. So then what we do is we want to use this key with the checked out blockchain. So we just use EPM keys use, and then we use the same number, name before, as before. And then if we do EPMRefs, you can see that the address associated with the checked out chain, which is the green chain in the table, the address has changed from the first time I did it to the second time that I did it. So at this point, we have a blockchain that it will be controlled and configured according to the genesis.json that we set up. We've made a small, we've made a key and associated that key with the blockchain. So now at this point, what we want to do is we want to deploy some smart contracts to the blockchain.
Casey, sorry to bump in. If you've still got genesis.json, maybe we could explain what the various parameters are and show people what the permissions are that they can set.
I think that might be a little bit long for the course of this video, but what we can do is I can go over a few of them. So EPM also has a plop command. We use plop basically as a machine-readable output format. So there are different things that are associated with a particular blockchain, which you can plop, and we display them: the current address, the ID of the chain, the configuration, the genesis, the key, if the chain is running, the process ID, and then after you deploy EPM, you'll have some variables, which I'll talk about in a minute, and you can plop those as well. So when Preston asked me to go over the genesis.json, then I just plopped the genesis. A few things that we can talk about. If you use a GenDug, which is the special contract that we put into the Genesis block, if you use it, you can see here that no GenDug setting for this particular chain has been turned on. So that has been set to true, which means that there's no Genesis Dug. But if you had a Genesis Dug on this chain, then what you could do is you could set up the accounts array, which is there, the last variable in the JSON. And for those accounts, what you would do is register a public key address and then a series of permissions that public key address can do and can do different things on the chain. And because of the GenDug contract being there, you can have an ability to restrict the nodes that are what we call committing, or other blockchains call mining, the nodes that are able to create contracts on the blockchain and the nodes that are able to transact with the blockchain. You can restrict those when you use the GenDug contract to particular accounts that you have established within the genesis.json array. And as well, you can set the difficulty. You can, even if you have a GenDug contract, you can set the public mine to 1. If you had changed the public mine to 1, that would mean that this chain would be publicly mineable, and so any Coinbase could mine a block on this chain, create, transact, etc. Ethan, any other highlights that we should go over on the genesis.json?
No, I think that's fine.
Cool. Great. So at this point, what we have done is we've used part of EPM's functionality. EPM has 2 main classifications of functionality. One is to manage blockchains. As we've seen, we've been able to create blockchains and deal with them. We've been able to change the current blockchain that we're using. But EPM began as a smart contract package manager. That's why the name is EPM. And for that functionality, we have we've built a whole series of small tools that EPM uses when it is deploying packages of smart contracts. So, can everybody see that I'm in Sublime now? Did it change on the screen share? Cool. So what you're looking at right now is the together deployment file. So this is a more or less like a package.json might be for an NPM package, or like a gem file might be for a Ruby gem. It's the definition of how this package is configured when it is sent to the blockchain. So this EPM has different command structures. It's a DSL for deploying systems of contracts. And what we do is you can see here, I'm just going to briefly run down through these commands. In the first step, what you have is you're going to deploy this contract, a contract at this path, and you're going to stick the create the contract that has been created, its address, you're going to stick it into a local variable called Doug. And then after that, you're going to do what's called a modify deploy. And you're going to take the account factory smart contract, and then you're going to stick its address into the AF variable. But before you deploy it, you're going to do more or less what is similar to an SED type of change, where you're going to where EPM will find this string right here that's highlighted within the account factory contract, and it will replace it with this newly highlighted string. And before it replaces it, it will do a variable escape of this Doug variable with whatever address has been assigned in the first step. So this allows us to link up contracts as they are sequentially being deployed. You can see that it does the same for the flagged contract. And then after that, what we do is we go through a series of transactions which basically set up the permissions table within the dApps Doug. We use Doug as sort of the center hub contract for a few different things, but this one is using a dApp Doug, as you can see, as the center of the dApp, which is different from the Genesis Doug contract that we put into the Genesis block of the blockchain itself. So you can see on transact, you're going to send a transaction to the Doug address, and then it's going to have this data associated with that transaction. So what I'm going to do is briefly going to deploy these contracts. So I'm going to set the log level quite high here, and we will just deploy the contracts. What it's doing behind the scenes is it's sending the contracts to a remote compiler microservice that we have set up. You can also set EPM to use them locally, and when it receives back the compilation, then it's going to go ahead and send everything into the virtual machine and deploy it.
Our peer server's down.
Oh,
that's not going to work.
That is not going to work. Oh, apparently our peer server is down, so the compile server is down, and I don't have the compilers installed locally. But anyway, we will get those back up as soon as possible. And but you wouldn't really be able to see much at this point beyond a whole lot of spam from the virtual machine. So we didn't have any deploys. So that's basically what EPM does. It's a tool for managing blockchains and managing packages of smart contracts. It allows you to work with dApps a little bit easier as well. So I think at this point, I think it might be beneficial to turn it over to Ethan for a little while, and then open it up to any questions that we might have.
Hey, sorry. So, on account of the peer server being down, I'm having trouble actually running any contracts because I don't have the compilers locally either. So that's not particularly good. Basically, what I could do is just show that. So let me pull up my In here. You sure? Yeah. Sorry, guys.
Or maybe I should mention then that what we didn't mention, or maybe Casey went through a bit too fast, that you should get EPM first.
Yes, yes, exactly. So installing EPM is quite easy. It's just it's a one-line command if you have Go installed, and all the instructions are at epm.io, which after this we'll put in the show notes for sure.
I can put it straight away. I think it's this go get thing.
Yeah, here, let me write it in the chat while Ethan's getting finished here.
Can you guys see my screen?
Yep.
Okay, cool. So basically the way EPM works is it builds everything out of this directory, just in your home directory /.d server. If you take a look at what's in there, we've got a whole bunch of folders, the most important one to us being the blockchains folder. And you can see I've got 3 different kinds of blockchains in here: Thelonious, Tendermint, and Ethereum. And basically EPM tries to be chain agnostic, and it does that by defining a simple blockchain interface. So we can actually look at what that interface looks like. It's relatively simple. Maybe I should zoom in.
It's totally readable.
Okay, cool. So this is the main idea. It's got a key manager and a D server module. Or sorry, it extends a key manager into a D server module. It's just to say it also has all of these functions. Key is we're going to phase that out and sort of separate the key management. But then basically to be a blockchain, you just have to satisfy these functions, and they're public-facing functions. So everything is string-based and hex prefixed, so you can begin all your strings with a 0x. And really the most important ones are basically these 4, which are what you can use to interact with the chain. So either send a simple transaction, or a message to a contract, or simulate sending a message to a contract, or actually deploy a new contract. And so you've noticed that, or you've potentially noticed that we've left out gas from this interface completely. And the reason for that was partly to simplify, but also we think it makes more sense to move gas sort of into its own submodule of the blockchain, so that we can have different gas strategies that are sort of implemented under the hood. So right now everything is just a hard-coded, this is how much gas it's going to allocate for the transaction, but moving forward we'll be looking to implement particular strategies. So it might do something like try and run the call, a simulated call, before actually sending the message to compute how much gas it's going to take, and then use that much, or other such strategies. Maybe there'll be services up where you can ping a mining pool and say, hey, you know, what's a good gas price for you guys, or these kinds of things. I'm sure surely someone will host services that serve how much gas a given contract takes, and so on. So for right now, we don't include gas for the sake of to make a blockchain compatible with EPM. All you really have to do is export that looks like this. So, and then once you do that, it becomes easy enough to use it with EPM, and you can specify what kind of blockchain you want, just like this, EPM new -- type, and then so we can have Thelonious, or we could have Ethereum, or we could have at this point Tendermint too. So if I just do that, it'll tell me, oh, it's already installed. So maybe I'll remove it just so we can see Ethereum. Let's do that. Great. So now I have a new Ethereum chain. It's not currently on something else. So my current chain is the Ethereum chain. Check out platforms, I can interact on that chain. So one thing I might want to do is see, just type EPM account. So these are all the accounts that come with the Go Ethereum Genesis block. If there were contracts, I could see those too.
So,
Funniest chain I had before. Yeah.
You seem to be cutting out now and again. I don't know if you're accidentally muting yourself.
Oh, not as far as I know. Is it consistently cutting out?
See if it,
It's intermittent. We'll be able to fill in the gaps for you.
Okay. Well, I don't think I'm saying too much important. If you can just see my screen, it's really demonstrating everything that matters. So there, I can see a bunch of accounts, and if I copy one of the addresses, I can go EPM accounts, and it'll tell me a little bit about that. In this case, this is a contract. Here's the code, and it has no storage. I'm not sure if any of these have any storage yet. Yeah, so this one has 3 stored at position 0. So this kind of functionality is actually about to be complicated by some changes coming to the Ethereum storage tree, because they're going to be hashing all the keys before they go in. So even though this is stored at 0, when you dump it, it's not going to look like 0. It's going to look like the hash of 0. The Tendermint blockchain actually doesn't do that, so it might be a little more convenient for inspecting storage. But we can do something like, we can do the same thing with the Tendermint chain, EPN type. Oh, sorry, that's not on the current branch. So you have to check out Tendermint branch to see with it right now. Go ahead and do that. But anyways, all you have to do is satisfy the blockchain interface, and then you can work with the chain just the same way you would any other by deploying contracts and testing them and so on. So unfortunately, our peer server is right now, so I can't actually demonstrate what deploying a contract looks like. But Casey went over the basics of the PDX file. So all you have to do is follow that. You should be good to go as soon as we get that peer server back up.
Which we realize has a pretty awful syntax, that PDX syntax, but we will hopefully be updating that, not in the current upcoming release, which I should actually talk about here briefly. So we will be we're hoping to move into an 09 release here very shortly. And we're not exactly sure when that will be, but it's coming, and we're pretty close with the milestones. If you're interested, you can track the milestones on GitHub. But after we release the 09, then during our work up towards the 010 series, which will be targeted for release later in the year, we'll be updating that syntax from the current sort of Ruby-esque syntax into a more agreeable JSON and/or YAML format. And so I think at that point we talked about everything. So EPM is just meant to be sort of a high-level command line tool that is able to manage different blockchains that you're using locally, be able to easily switch blockchains, and then also be able to easily work with packages of contracts, as well as it will run a blockchain, and that's basically it. So if anybody has any questions, that would be great.
Chris, any questions from the wider public?
Well, no, not yet. We don't, but I can offer a few questions. So,
fire away.
So one of the things. Hello, everyone.
I get to be the cameraman now.
Right. So one of the things that I've noticed about Eris is it does resemble, to quite a large extent, basically a Git repository, right? In the sense that it's a simple state machine that tracks the transition of events across time. And I was wondering how much it was different to that. I saw you going through the parameters. Are there any tokens at all that get issued as a way of transitioning the state? Because the way it does it on Bitcoin is, in order to transition the state, you have to have a token to begin with. So are there any tokens at all?
There are tokens. We are hoping, hopefully by the 010 series, that there will be no tokens that will be hard-coded into the blockchain, client. The tokens for Thelonious, as we are working towards. Now, I should say that Thelonious, the blockchain, is a library, just basically how Ethereum is a library, as well as Tendermint is a library. And EPM wraps those different libraries and then runs them as the sort of operational blockchain. And so this is what we're really talking about here is in Thelonious. And so in Thelonious, we will be hopefully, the idea is to move tokens into being a smart contract enabled thing rather than being enabled or hard-coded into the blockchain client itself when we're talking about Thelonious. So tokens can be there or cannot be there depending on the smart contract consensus. Well, the consensus smart contracts, which have been compiled and linked into the Genesis block itself.
I think one of the sort of a general point, people have said, you need you need tokens to secure a blockchain and blah blah blah. That's just, that's a security strategy for most blockchains. But once you actually have that expressed in smart contracts and you can limit who's actually committing new blocks to that chain, all of a sudden the security profile changes. So if you can say nodes 1 through 100 are the only ones that are allowed to add blocks to the end of this chain, and you specify that in the smart contract in the Genesis DAO, then what happens is those blocks are the only blocks that are adding it to the end of the chain. So at that point, what's your security strategy? It's how useful the blockchain is in that context. So it's what data you need to get verifiably transmitted between the various users of that system. And the data is primarily constituted not as a token, but as a contract, as a script. And then that script has meaning, in the context of the system that the blockchain, or the function that blockchain is carrying out. So if it's a blockchain where you're doing, for example, bondholder consultation, Casey always tells me to avoid the banks, or some other kind of voting mechanism. Then what happens is that blockchain lives in a context like any other database. And so what happens is you get this record of how everyone is interacting with each other. And that record is very hard to forge and very hard to reverse. Or if someone, one of our guests here in London, who I'm not going to put on camera, as he mentioned earlier, the benefit of that is that if someone does, with Bitcoin, it's possible to 51% it. But it's a game theoretic question. If you did 51% it, what would happen? Everyone would see exactly how you did it. So, and they would be able to track it all the way back to the point where you did it, unless you were recomputing the entire chain from scratch, in which case everyone would really be able to tell that you were doing it. So this is something where within a real context, within normal commercial tolerances or governance tolerances in the real world, what you're using the blockchain for isn't to absolutely prevent someone from messing with data. But when someone does mess with that data, you have this perfect record that you can see that it's been done.
Yep. Yeah, exactly. We should do a separate topic on blockchain security, because that's not really. I think that is a whole nother rabbit hole itself, and probably worthy of an entry alone. So one thing that I didn't mention before that Andreas reminded me of is that we are reworking our web-based graphical interface for EPM and the blockchains that it's running. At this point, that work is still going to be a work in progress here for a little while, but this will be all available from a web-based GUI running in any web browser. So even though EPM is a command line tool, it will also be able to provide an API and RPC interface which can be used by a web-based GUI. Or accessed by a web-based GUI, so you don't have to use everything from the command line. Also, we are implementing, as I said just now, an API for EPM, so you'll be able to talk to EPM nodes from wherever you are. If they have their API ports turned on, then you'll be able to talk to which might be running a Tendermint chain on an AWS server in northern China, you'll be able to talk to it and send it commands to do all of the command line, most of the command line functionality that we set up before. If you have the proper parameters to talk to the EPM instance, it could be running a Thelonious chain in a DigitalOcean server in Sao Paulo, and you could be in Antarctica if you wanted to be, and you can do everything from there. So we will be pushing both an API and a more bolstered RPC client for EPM in the 09 release, which is upcoming.
That's great. I also wanted to remind everybody that you can ask us questions by clicking on the link below. It takes you to a new window, and you will see an extra side column on the right-hand side, which will let you have your say. So please do get involved. Also giving a shout out on Twitter as well. Any other points you wanted to cover?
Not me. This is really just questions from the public and from you. Anything that you think is.
So I wanted to know what kind of use case do you think you're going to see using Eris? Because one of the ways you described Eris to me was like Ethereum, but for everyone. So anyone can set up their own Ethereum-like chain. Have I understood that correctly?
I mean, I suppose the brilliance of Ethereum is really unquestionable, and that's that you can program a blockchain. It's scriptable, and so this just extends that principle to the entire blockchain itself. So you can tell it to do anything you want. You can then make an application that displays in any way that you want. And so people say, well, what are the use cases? And then you go, well, it's a database. How do you? That's like asking someone, how do I use a database? Mm-hmm. Which is a pretty general question. But then you have to look at things like, what's a blockchain good at? It's good at harmonizing information between multiple people across great distances in a really verifiable way. That's the starting point. In the meantime, hey, so good 40 Foxes, or otherwise known as Dead Marmot, has just arrived. So where was I going with that? So you can start with something really, really simple, like if you were, if you wanted to verify one user, one instantiation, and you just wanted to make sure that no one, the NSA wasn't reaching into your hi NSA, by the way. So you wanted to make sure that they weren't going in and fiddling with your data, and you wanted to, for example, you just have this database, you want to checkpoint it against a big bad public chain like an Ethereum or a Bitcoin every once in a while to make sure that its state is valid. And then what you do is if someone goes in when you aren't looking and then fiddles with your database, you're going to be able to know that they've done that. So that's a very limited use case. On the other end, you're looking at stuff that's very infrastructural, data infrastructure that can survive a nuclear war. So those are the two extremes of what you're looking at. And so this allows people to do everything in the middle. We've got a ton of stuff on the website which describes, how increasing verifiability for small business is relevant, how automating or creating really blockchains, they're databases, but they're also databases paired with protocols. Now that you can script it, you can more or less script a protocol to do something. So you could have something like a payments protocol which runs on blockchains, which doesn't require one database to do it, but has 1,000, 10,000, 100,000 mutually intelligible data structures, right, which are able to talk to each other because we have this thing called the D server. It's both a client program and an Oracle machine that can talk to two databases at once.
So this is the issue in database design called database ownership, which traditionally was left to some geek who could SSH in anytime he wanted into a server and just change any entry in a database. Mm-hmm. That's one of the features of databases, that are mutable, that you can go in. In fact, most developers spend most of their time managing databases, changing entries because mistakes were made. So really what we're talking about with these blockchains is that now it's a shared consensus that everyone has access to change entries. They just have to prove they have the key. That's correct?
Well, I mean, depending on how you set it, the key point from a sort of practical perspective is that when someone changes it, and you can change an entry, and you can tell the system, okay, ignore this, now do this, but you have an audit trail which is immutable. And so if you're sharing that across multiple entities or multiple individuals or multiple organizations, whatever you like, you have a more or less immutable record of how that's being done, assuming that all of these entities are watching that data and keeping track of it. They're going to be able to see if someone messes around, at which point they get them on the phone and they say, what the hell are you doing? Yeah. So it's a very different approach than something like a Bitcoin where it has to work in all circumstances. But the same principle applies. Again, it's just a very different type of profile where that might arise because it's an international money system, which not all blockchains need to do that.
So one of the examples you brought up then. So this could be used by a smallish or a group of banks for like interbank lending or this kind of thing. So you would have, say, let's say 5 or 6 big banks that would use a shared blockchain, and then perhaps they could also share it with a regulator too, that could then monitor. Because at the moment, what regulators do is they come in and they take a random sample of the audit, which means that you can still get away with things. You can still kind of scrub out an inconvenient entry here. But with your one, you're suggesting that the regulator would have the blockchain as well, and they could scrutinize it on a whim.
Before we get onto that, I think blockchains are no longer just about banks. Because Bitcoin is a financial product, people have focused on it as a financial product. They are a database tool. So when you're looking at what functions they can perform, they can do anything. And so we're trying to get blockchain away from banking. I think it's one of those spaces that, because of where it's come from and where Bitcoin has come from, they're one of the spaces that's paying closest attention to it. But really, this can work for just about anything else as well. One key use case we have is using it for land registration in developing countries, or any other kind of governmental audit or infrastructure in developing countries, where you have a low-cost data infrastructure, where you don't need to run web servers, where you can get something which is really transparent, really reliable, and really secure up and running very quickly, as long as you know how to describe it in code.
Yeah.
So before we answer that question, this isn't about banks anymore.
Okay.
It shouldn't be about banks anymore. It should never have been about banks in the first place. This is about giving people tools so that they can interact with each other securely and verifiably. As to the second question, yes, I mean, this is something where you get if you have a system which is running on a blockchain, you have a 30-second up-to-date view of what's going on with that system. Every block you can say, right, this is what's just happened. So you can do things which are pretty interesting once you have that. You can sandbox it, and you can say, all right, let's see what happens if, and this from a regulator's perspective is really interesting. So let's say you do something like a data room, where the regulator has access to the data, but the banks are not going to be wanting to share their data among themselves. They will want the government to have custody of it, and then say, right, we're going to do a stress test. The EBA will do a stress test. So you do something like a stress test. You can see how all of these databases interact with each other, sandbox it, and then say, all right, let's see what happens if we jack up LIBOR by 10,000 basis points. What happens to these particular derivatives exposures? And you can test it, and you can simulate, and your simulation is based on the real exposures of that bank data, and you can see exactly how those changes will cascade through a particular system. And finances, the financial system is a system, so it's not going to be perfect, because you can't tell what people are going to do, whether they're going to renegotiate deals, whether they're going to not pay collateral or something like that. But you can get a pretty good picture of what's going on in those systems, as long as you have an agreed framework that those systems are operating under. And so this is a really predictable way to do that. So yeah, this is something which, from a regulatory perspective, in terms of supervising the financial system and managing the risks of the financial system, that's something which could be highly beneficial. One thing that we've also talked about is that this gives the ability for the central banks to do a lot more. And I know that's sort of a 4-letter word in the Bitcoin set, but imagine you had a central bank depository system where it was nil risk and you could keep your money, and then all of a sudden you have a totally separate system, which is commercial risk, where it's, okay, right, you want to keep your money in the commercial system and get a nice big stonking rate of interest, you go right ahead and do that. You're not safe anymore. There are no guarantees. So what you've done is you've created a safe banking system so that you don't have this ring fencing. Ring fencing is a huge pain in the ass for the banks to do. So instead what you do is you just offer an automatic bank for your own citizens and your own residents, and you say, this is your safe place to keep your money. It carries zero interest, but there is zero risk, because it is the central bank, and the central bank effectively is money. So there are a whole bunch of things you can do in terms of restructuring the financial system with this kind of a data structure.
Yeah, and it also sounds like it's lowering the barrier to entry. Because,
completely. Yeah, completely.
So even a small group of people could set up their own bank, and they could set up their own financial services.
One thing that strikes me about what we've done is that the idea that you can roll a blockchain in 10 seconds and just go, okay, here's a new chain, bang, and you know that it's going to do what you told it to do. That's really interesting, because once you have that kind of an infrastructure, people think about Bitcoin as this giant, lumbering, irreplaceable dinosaur. Okay, what if we trim it a bit, tell it to do something really specific? Once we know how to do something once, we can do it now 100,000 times, 200,000 times, 1,000,000 times, really without that much of an adverse consequence. So you look at the blockchain suddenly as something a lot more flexible, a lot easier. Okay, well, I need a blockchain for this because I need data infrastructure, I need it now. Boom, rolled. I need it for this. rolled. I need it for that, rolled. And yeah, that helps the little guy as much as it helps the big guy. So that from the big guy's perspective, it's about cutting their costs and managing their business. From the little guy's perspective, it's about leveling the playing field and being able to deploy that kind of infrastructure in a really rapid and secure way, where they can mathematically prove that no action is going to happen that they don't want to happen, and they don't need web servers for it or anything else. You just roll it, you set up a couple of nodes, and you're off. So from that perspective, yes, that's the democratization of finance. In a sense, people say a lot of things about Bitcoin, which we all like at Eris Industries, but democratizing finance is about improving the ability of people to provide and have access to financial services which are low cost. And so once you can describe, and financial services is a process. You said earlier, bankers basically play computer games all day. That's what they do. Well, okay. The game has changed. Now everyone can play computer games all day as long as they've got the relevant licensure. This is the infrastructure to do it. And you can even have your members. Let's say you've got something like a credit union or a building society. Your members administer the system.
Yeah.
Why not? So that's really interesting.
Yeah. Well, does anybody else on the guests have any questions for us? David?
I'm particularly interested in what you were talking about in terms of ring fencing. And from my point of view, I come from not the kind of Bitcoin world, the financial world. I come a little bit from that aspect, but also from democracy and the idea that you can create token exchange systems which capture different forms of value, not just goods and services, but might capture different forms of value. So the idea that you can set up sustainable ring-fence systems with feedback loops of consent and agreement between its members that are designed to capture a particular form of value and are not on a completely different, you call it database, but completely almost different operating system. That's what really fascinates me, and I'm wondering if you can let us know why, what the different approaches to addressing that is, and if having separate blockchains is the only approach, or whether you can do them, for instance, by having DAOs for these separate entities, for instance.
There's a guy actually named Daniel Nace, I think his name is, and he's running a startup in Crypto Valley in Zug, and it's called, what is it called, Koina. And basically Koina is this idea that you ledgerize interactions in a closed system. So what you do is you issue credits based on, so it's like an alternative currency, but not in the sense that there's a crypto token. It's, I'm making 10,000 loaves of bread, and I think that it's worth X in this economy, and I want to trade it for other goods and services. So instead of credit-based financing, his idea is that it becomes production-based financing. So it's, I have these credits in respect of these goods. I will produce these goods at a later date. So I now have these credits which I can deploy, which are backed by the production of these goods. Whether that's viable or not, who knows? But one thing that this does allow is it allows a community to say, okay, we need a data structure that does this and records it very reliably and very efficiently. So if we can script it, and that's what he and I think Ian Grigg is working with him as well, and that's what they're working on doing. It's this idea that you have a social contract among a group of people where it's very heavily reputation based. You can then predict, you can then record, okay, I'm issuing this much production, how much, standard unit of value is this worth, and you can do that by communicating with the market and then say, right, I have this standard value against this particular unit of production which I promised to deliver at a later date. So, yes, this is something where people can set up a consensus arrangement among themselves where all the parties are generally known, and you're not needing a web server to do it at this point. You're just saying, right, cool, so we agree, these 10 businesses that we use goods and services and trade them back and forth amongst ourselves. Well, why don't we just set up our own system? And that's I think the difference between a private chain and one of the big bad public chains is that you can set, there are other kinds of networks in the world. There are people who know each other. There are people who owe each other favors. There are groups of friends who have betting pools and gambling pools. And do you want to put that on a big bad chain? Maybe, maybe not. Do you need to pay for that kind of global security for an application which is fundamentally micro? Probably not. If you can find people and you know where to how to enforce against them effectively. That changes the dynamic. And so from our perspective, this is about allowing those smaller networks to just say, cool, we want to interact with each other. We want to make this really quick and easy. Click, click, boom, blockchain. And so you just run a couple of nodes, 200 users, 300 users, whatever. And they've got the system which they can plug into, which they know no one else can use, which they don't need a server to run it on, which they don't need to pay anyone for. Casey calls it participatory architecture. And so the idea is that you are participating in the management and security of that application when you use it. So that, does that kind of answer the question, or ish?
Yeah, well, it goes way towards it. My sort of architectural question is, in a way, you could do quite a lot of that by creating a DAO for each network, a membership DAO. So what would you say the main difference between rolling your own chain is and creating a DAO on a single chain?
I think it's just what we call it. I mean, a DAO is a name for a concept, and that concept is a group of people coming together for a common purpose with common rules. So if you had a chain which you're putting a DAO on, like Ethereum, and it made sense to do it on Ethereum, then do it on Ethereum. If it doesn't make sense to do it on Ethereum and do it on your own chain, do it on your own chain. So it's just, I mean, DAO is the idea of, legally it's meaningless. What it is, it's kind of a rough sketch of self-organization going forward in the future, and a lot of bumping and bumping going on here at the escalator. So yeah, a DAO is just code. The question is what you want to do with the code, and how you structure that particular application. But generally, a DAO, I think, has a blockchain involved.
So technically, a DAO can run on two chains at the same time, as you mentioned. One can be a private chain in the organization, and then every now and then it just talks to the big one.
50 or 100. I mean, as long as you have an agreed system of rules, and you know that those data structures need to talk to each other in order to achieve that objective. And you could have Bitcoin involved in the DAO. I mean, one of the things we did on our YouTube tipping app, or YouTube app, was have a Bitcoin tipping function. There's a lot of talk about, oh my God, this competes with Bitcoin. No, not at all. What it is, it does a different thing. Do you want to put YouTube on Bitcoin? No. Do you want to create an architecture so that people can come together, share content in accordance with agreed rules, and then you can tip them in Bitcoin without needing a central counterparty in order to do it? Yes. So that's what this is about. It's distributed infrastructure, which is opt-in, which people can set up to address a very particular purpose, and then leverage other distributed technologies. This D server that we have, the client, is designed to allow people to write modules that plug into other databases, Ethereum, Tendermint, IPFS, BitTorrent, whatever. So the idea is you can set up an infrastructure, get your utility from the distributed internet, and then have a predictable way of harmonizing all of those different databases in a single application. Once you have that, then you can do something like set up. It's kind of like ChangeTip, cheap. This is a cheap plug for Chris's app. I'm not ChangeTip, but ProTip.
Mm-hmm.
So ProTip, the difference between that and ChangeTip is that ProTip runs locally on a user's computer. It's a framework for that user to interact with Bitcoin and content on the internet, and then send that Bitcoin in a batch automatically at the end of a week. The difference between that and a ChangeTip or a Doge tip bot or something else is that when you're using ChangeTip or Doge tip bot, you need someone else's server to carry that function out. You're exposed to the server. You don't need to. We all have more hard drive space than we know what to do with. We have more processing power than we know what to do with. So fuck it, let's use it to create our own infrastructure.
And that's also where computing began, was a client-rich environments where I had root access to my hardware, which is, by the way, diminishing now. I have root access to this stupid thing. And I don't control the hardware, and therefore, as Stallman would say, the hardware controls me, and I'm always at the mercy. Like last night, something happened on Twitter. Twitter brute forced an update onto everyone's phones that now gets rid of the Discovery Activity tab, where you used to be able to discover trending conversations between your friends and their friends of friends. So it gave you, for people like me who have severe ADHD, it was a really good feature because I could get to see what was rising, what was, and then there were people that I wouldn't follow but I could still be interested in. And so it had these weird kind of social nuances too, where I wouldn't want to publicly be seen to be following someone, but I could still be exposed to some of their comments. And I thought it was great. And then all of a sudden, they just pulled it, forced an update without anyone's permission. I just saw it updating in the background going, I didn't request this. And suddenly I'm being, now what they're doing here is, and I love to quote Carl Schmitt, is that the sovereign is the one that defines the emergency. right? So if you define what's next for people across a terrain, you're in charge of those people. And that's essentially what these organizations have become. You are less self-determinant now, and you're more really, you're basically sleepwalking your way through life. They're helping you make your decisions. Google tells you what's findable on the internet. Google is the internet because it's the table of contents. Twitter will tell you what you should care about next. Facebook should tell you what sort of pictures you should be looking at. And really what we're trying to do, I think both our organization and yours, is we're trying to give people back control to help them make better decisions in life, like particularly with ProTip, where it basically tells you, this is what you spent your time looking at this week. That should make you automatically in its own right. That's a pretty useful app to have. And of these people, here's the top 10. Who would you like to subscribe to? Who would you like to ignore? And it really just helps you, like we're doing the same thing that advertisers do already, okay? You go to a website, download the Ghostery app, look that up. And it will show you all the scripts that are running in the background. So you're downloading a whole bunch of JavaScript, and they're giving you cookies, they're taking your IP address. If you signed in already with an email address, they'll start to sell that data to one another, consolidate it, and they are basically monitoring your time. And I said, no. You have one app that runs in your browser, and it monitors your time, and it's your data. It stays on your computer locally to you, and it's about getting that data and helping people's data, make them smarter about who they are, rather than just selling it off to someone else for commercial ends.
The reason we've structured this company as a business is because that same idea of control over your data is something which corporates want as well. I think a lot of the Silicon Valley model has been dependent on take data, aggregate data, sell data. And a lot of what this sort of, you see a lot of this now in the blockchain space. It's about, take your financial data, run it through some servers, run this big financial network. And if you talk to a bank, they go, no, we don't want that. And neither should anybody else, to be perfectly honest with you. So this is about getting, reducing dependence on those stacks instead of creating a new stack which does all these things for us. And this is, particularly relevant. One guy hopped into our what did he do? He hopped into our Skype room or IRC channel, and he said, okay, I've got an idea for a blockchain application, and everyone has said it's stupid, so please don't make fun of me. And I was like, all right, but I'm sure it's not stupid. Tell us what it is. And he went, I want to have a system where I can verify that I've delivered. He's a programmer, but he's also a pizza delivery guy. So what they're doing now is they kind of have like an Uber for delivery people, where you don't get paid. So what you do is you pay for the food, you go to the house, you deliver the food, and then what happens is there's no, you deliver the food, and then you go do something else. You don't get paid if the person says the food wasn't delivered. And he's like, how can I get a really 100% verifiable record that this has happened? What if all the delivery guys in town said, okay, well, hey, guess what? No one's going to do this service for us, or if someone set up a server, we'd have to pay for it. But why don't we just run a delivery verification app? And if you want to work with us and you want us to deliver your food, you've got to tell your customers that when they're ordering food through this automatic service, they are then required to download this app which verifies that blah, 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 blah. And that same principle applies to something like an Uber with cab drivers or a Spotify with musicians. And so the idea is that all of a sudden, because you can get the data functionality with these people, they can start making demands, and they can say, we keep getting screwed because your customers say we didn't deliver the food when actually we have. Make them use the app or integrate this functionality into the app. We've got a record it's happened, they've got a record it's happened, you've got a record it's happened. We stop getting screwed when we deliver food in 20-degree weather in Boston. But this is where it was like 8 feet of snow, 10 feet of snow in Boston.
He comes and Fahrenheit.
20 Fahrenheit, sorry. So this is like negative 10 in centigrade. So it's he's freezing his ass off, and people are screwing him on food deliveries, which is ridiculous. And they have no power to actually go in and say, well, we want this to change. This particular process doesn't work for us. And you can see this everywhere. So it's taking the responsibility and the power from these software providers and app providers who you need to pay to give you a service. And you say, well, fuck it. I need this data functionality. I'm going to build it myself, and then I'm going to benefit from it. And so he said, yeah, people have said this is a ridiculous app. And we said, no, it's absolutely perfect. This is what blockchains were designed to do. And if you talk to someone in Bitcoin, maybe it is a stupid app. But if you talk to someone at Eris, this is bread and butter for us. And this is exactly what we think they should be used for.
Great. If there are no more questions, I guess we could cut it there.
Sounds good to me.
Great. Cool.
Well, thank you very much, everyone, for joining our EPM Dev Hangout. We are having another international Marmot video party in I think a week and a half's time. You can check out our meetup page. We've got Eris Limited is the main meetup page. We have also got our new Silicon Valley meetup page, if that's the kind of thing you're interested in. So in a week or two, Casey will be in Zurich. Presenting all kinds of tech things about Eris, and then I will disagree with him on a lot of stuff and present from London on commercial matters here at the Barclays Accelerator. There will be beer and chips, so everybody is welcome to come, and you will be fed and given alcohol so that you like us. Anyway, I think that's about that. So thank you very much for watching, and hopefully speak to you guys soon. Any questions? We're erisindustries.com, or Eris Industries on Reddit, or hashtag Eris Industries on Freenode. Right.
Cool, guys. Thanks very much, everyone.
See you guys. Thanks.
Thanks. Bye-bye.